is your...
Hello, so I'm Gabbrielle Simard-Moore. I studied some geochemistry back in college, and so when I was taking a graduate level class in geophysics, I relearned the same exact way to calculate the epicenter of an earthquake as I had done in high school earth science. And apparently this is still the standard method, so I'm going to walk you guys through the very manual way that it's done and then show you how I figured out how to automate it a little better. So there's basically these 5 steps if you boil it down to something. You have to get data from 3 seismic stations. You have to get the difference between the primary and secondary wave arrival times. And then you have to use that to get the distance to the earthquake. Then you get a map and draw 3 circles. And then the intersection of those 3 circles is the epicenter. So this is what a seismograph basically looks like. You have the P wave, the S wave, and then you also can get a maximum amplitude from the long parts on the right. So now once you get the difference in P wave and S wave arrival time, you look at this graph on the left and you draw a line from the difference in time and then go down to see what that correlates to in the distance in kilometers. And you do the same thing for finding the magnitude. You look at what the maximum amplitude was and what the distance was, and you draw a line across that graph with a ruler. And then where it intersects in the middle is your magnitude. So I figured, okay, there's got to be a better way to do that. And then this is the final step. This is you get a map out and you draw 3 circles based on the map scale and the distance from the earthquake at each seismic station. And so some of you guys may remember doing this in your high school earth science classes. And apparently this is still done. So I was like, oh, come on, there's got to be a better way. So let's try calculating this with Python. So here's what I used. I'm using Python 3.6, NumPy, date time, and math, the math module, and some actual math. And then I and then I eventually made a front end for this with Flask, Ajax, jQuery, and the Google Maps JavaScript API. So just have to list that there are a few assumptions made in the calculations that make them imperfect. You have to assume an average wave velocity of the P and S waves through the Earth's crust and assume homogeneity of the Earth's crust, which is not really realistic. There's actually a lot of materials that those waves can deflect off of, and so it's not always perfect. But I ended up deciding to focus on California crustal rocks and looked at these wave velocities as an average. So first off, I have 3. I'm actually going to be skipping a few steps just because I had to narrow this down. But first, I have 3 stations, and this is just my doc string with all of the steps that's going to be in just calculating the epicenter, which I've kind of outlined. And then so I take in some latitude and longitude coordinates and then convert those from degrees to radians. And then I take those latitude and longitude coordinates and convert them to ECF XYZ coordinates, which stands for Earth-centered, Earth-fixed. And then putting those into a NumPy array. And then I do some vector normalization and some intermediate steps in my calculations, which is doing some dot products and cross products and all this linear algebra. And then I finally get a trilateration point, basically doing this triangulation of finding where 3 circles intersect on the sphere. And finally, there's an error I was able to catch, which was interesting, was if you manually enter the P and S wave arrival times backwards, then you get to catch this seismic error that you may have entered those backwards. And then you return the epicenter. And finally, this is what the front end looked like. And so after doing all of that, so I made this data entry form, and then after it actually just calculates the epicenter, and then I'm using Google Maps to draw 3 circles around each seismic station. So as you can see, it's not perfect. I think that some of those assumptions made in the calculations make it a little bit off, but it didn't. The epicenter, which is that point that's kind of on the left, bottom left, it didn't land in Australia, so I'm pretty happy with it. Thank you.